Good morning, good afternoon, everyone. Welcome to today's NextFlex Proposers Day for Project Call 11. I'm Scott Miller. I'm the Director of Technology at NextFlex, and I'm joined today by Dr. Nick Morris, our Deputy Director of Technology. It's our pleasure to run you through information about Project Call 11, which is titled Resiliency and Efficiency, as well as to moderate this session from the Proposers Day portion, the partnering event portion, for potential proposers, interested parties to share their ideas, their capabilities, and what they may be looking for in a team that they're either intending to lead or join. So thank you all for being here with us, and we're really excited to be at this stage for Project Call 11. Go to the next slide, Nick. A quick disclaimer before we actually start into the presentation. So NextFlex is partially sponsored by the Department of Defense through a cooperative agreement sponsored by the Air Force Research Lab. So when we are describing, our opinions today and sharing information, they are our opinions and not those of the federal government. Next slide. All right. So within the Proposers Day and teaming event today, we're going to cover a lot of ground. We'll give you some resources, some background on NextFlex for those of you who may not be familiar. We'll talk to you about the Project Call 11 process, schedule, and themes of the call, giving you an insight into what really the background is for it, and then specifically into the three topics for the call. We'll talk to you about the evaluation criteria, how we go from receiving proposals to those that are selected for funding. We'll have time for Q&A. We'll answer questions for you, and then we'll move into the teaming event when we turn the floor over to all of you to present to each other. Next slide. So if you're looking for additional information, things that we don't cover here in this webinar, or you need to get into the details of it, we'll refer you to the Project Call 11 page on the NextFlex website. You can see the URL at the bottom right corner. There is some description and links to a number of documents, including the Project Call guidebook, an FAQ file, and all of the other information that you need. If you have questions, you can always email us at proposal@nextflex.us. Please use that address. And that'll be distributed to a number of us within the Institute who can answer questions based on our particular areas of expertise. We can also pull in additional resources that way. But using that address will get you the quickest response. Next slide. So talking through some of the initial background. Next. NextFlex is one of 17 Manufacturing USA institutes, and specifically one of the 9 that are sponsored by the Department of Defense. Each of the institutes within the network focuses on a different area of technology, and for NextFlex, that is hybrid electronics. So in the area of hybrid electronics, we focus on a mission that aims to strengthen the US manufacturing industrial base for this technology. We do that by advancing the technology and the manufacturing capability, strengthening the industrial base, and securing human capital. That's creating the workforce that we need both today and tomorrow across all of the various aspects of the hybrid electronics field. Next slide. NextFlex, as a manufacturing innovation institute, has been around now for more than 10 years, and this is our 11th annual project call as a consequence. We're based in San Jose, California, with partners all across the country. We have more than 200 industry, academic, and government organizations that partner with NextFlex through our membership. We also have 4 state and regional hub activities in New York, Massachusetts, Missouri, and Alabama. So if you're in one of those states in particular, I would strongly encourage to connect with those NextFlex nodes in those areas, and we can make those connections for you if you need help with that. Over the 10 years of NextFlex's existence, we have run more than 300 projects, combination of our project call portfolio, of which PC11 is our 11th installment, and our agency-driven project portfolio, which has a total project value between the government funding and the cost share of more than $450 million over that 10-year period. So there's been substantial investment and a myriad outcomes from those projects. Those include things like manufacturing tools, processes that have been developed and implemented into factories, products and prototypes that have gone into DoD programs of record, onto platforms and into industrial products, as well as a very strong integrated knowledge base that exists and is accessible to the NextFlex membership. So if that's something you're interested in gaining access to, if you're not already a NextFlex member, please speak with us about that. That is an important factor in PC11, at least post-selection. Next slide. When we talk about hybrid electronics, what we really mean is additively manufactured electronics that combine printed elements and electronics assembly. So printing portions of a device using a variety of additive processes for electronics fabrication, and then using integrated circuits, passive components, other components that are placed into the system, but not actually manufactured through the printing. By doing that, we're able to enable a number of different kinds of devices, things like shown on the right-hand side. Flexible devices that can be used for asset monitoring, edge devices, industrial IoT devices, applications in aerospace and defense with advanced communications, with antennas, with a variety of sensing applications and so forth. Medical and wearable applications, RF and communications devices operating at high frequency, for example, low frequency, additively manufactured, structurally integrated systems. So flexible, but also structurally integrated, conformal, 3D, and not restricted to low temperature devices, but also work at extremely high temperatures and low temperatures and in harsh environments. Next slide. The industrial base that we support really spans the entire spectrum for this field. To be successful at what we do, we need to integrate the entire industrial base, from companies at sort of the left side of a supply chain, back up, Nick, thanks, like materials companies, equipment manufacturers, design companies, and software companies, all the way out to the right side of a supply chain with the OEMs in areas like industrial, aerospace, and defense, medical devices, and wearables. On this slide, you see the logos of our members and a number of our partners on the industry and academic side. This represents a fraction of the total that we impact through other types of partnerships as well. Next slide. For our government programs, we partner with government agencies, including very strongly in the Department of Defense, our program sponsors, but also a number of other agencies within the federal government with whom we've either run programs or from whom we draw subject matter experts into our technical working groups, our road mapping activities, project sponsorship, and other areas. So we can make connections in these spaces. That really does help in areas of technology transitions, for example, and getting the development work that's done through the Institute out into the field. Next slide. NextFlex focuses, and as all of the manufacturing institutes do, focus in the mid-TRL range, looking to span the valley of death. So within our project calls, it's really important that every project has to be at TRL and MRL4 as an entry point and cannot go above TRL and MRL7 as the exit point. That does not mean that every project needs to start at 4 and get to 7. That would be unlikely for most projects to be able to move that far in the limited timelines that we provide for these projects and with the limited funding that's available. There can be some projects that do that, but that's the range in which we focus with the core funds and the project call funds that we apply in this space. So for those of you who are not familiar, there are plenty of good references. If you go to the NextFlex Project Call 11 website, we have a link to a presentation about TRLs and MRLs. TRL4 essentially means breadboard development in a laboratory. There is a lot more to it than that. That is just a simple summary of what it means. There are many more requirements. TRL7 means a prototype being tested in an operational environment. That's not a representative environment. That's TRL6, but an actual operational environment. So that gives you the span of that technology. From a manufacturing readiness level standpoint, again, there's a page-long list of what the requirements would be at a particular MRL, and the MRL desk book is a hefty book that talks through all of the details of each of those each of those MRLs and how to do assessments. But at MRL4, we're talking about having manufacturing processes in a laboratory environment. By MRL7, you have the system or the subsystem in a production relevant representative environment. And so huge span of development required in there. There are also elements, things like what is the supply chain? Do you have all of the elements of supply chain with multiple suppliers? So many different aspects that have to be advanced. Next slide, Nick. Actually, I'll hand over to you now for the rest of the presentation.
Thank you, Scott. Good morning, good afternoon, everyone. So I'm here to walk you through the process that led up to the topics that were selected in Project Call 11, all the programmatic details that are found in the guidebook. So anything I say, always refer back to the guidebook as the ultimate reference, but I'm going to step through the schedule, the major themes, the process, and then get into the topics themselves and what technical areas of focus we have this project call. So I want to start with our technical working group. So thank you to all on the call that have participated in our 11 technical working groups over the last 6 or 7 months now on our road mapping cycle. So if you're unaware of our technical working groups, Scott mentioned them. They are made up of subject matter experts across our membership, across academia, industry, our government partners in 11 different technical focus areas. So 5 of them are what we call the manufacturing thrust areas. Those are the enabling manufacturing technologies that enable hybrid electronics and scale them up and prepare them for transition. The 6 that are more application focused are technology platform demonstrators. Those are the ones that really showcase new capabilities possible utilizing hybrid electronics approaches. So these are the 11 groups that put together our roadmaps. The subject matter experts contribute in terms of where their technical pain points are, where the gaps are in the industrial base, identifying transition opportunities, and then formalizing those in a 5-year time horizon roadmap. So each of these 11 technical working groups just published on our member portal that's available to NextFlex tiered members last week, the latest version of these roadmaps. So if you haven't checked out the roadmaps recently, please access the member portal as a NextFlex member. If you need help getting credentials, please reach out to us. Happy to provide those updates. There are 2 versions of the roadmap. So that the version I'm describing, the deep technical narrative, all of the figures in terms of describing all of the technical gaps, prioritizing those technical gaps, really focusing in on what needs to be addressed in the near term and in the longer term. Those are about 20 pages each in length, about 200 total pages of technical narrative. Each of those are on our the respective technical working group page websites on our member portal, only available to NextFlex tiered members. Several years ago, we did start publishing a summary of those available on our public website. So taking each one of those about 15 or 20 pages per roadmap, distilling it down to a single page per technical working group. So about 15 total pages. And that is on our public website. So you can find that on the PC11 website with a link in this document as well. In terms of the topic development, so once we go through that 6-month or so process of getting the technical working groups together, working one-on-one with subject matter experts in industry, academia, and government, understanding what needs to be accomplished, that then directly feeds into how we develop the topics for the next project call. So through the working groups help develop ideas for project call topics. We formalize those, we share those with NextFlex's technical council, which are made up of technical experts across our membership to make sure that we prioritize those topics, further refine them, and make a recommendation in terms of what topics should be selected for each project call. That then goes to our governing council, which is made up of the leadership of the Institute to approve those topics, refine those to make sure that we are balancing the long-term strategy as well as the portfolios of funded projects. So that was the process we went through in the last couple of months, leading up to the selection of the 3 topics that are in this first part of Project Call 11. So that full process, so we sort of worked our way through that first block of roadmap-based topic development and launch of the RFP, the request for proposal, last week. We are now entering into the phase of pre-submission consultations, which I'll mention in more detail later, but this is a one-step proposal process. We do not require a white paper phase. We do strongly recommend that potential proposers reach out to us and schedule a pre-submission consultation call, typically a 30-minute call with Scott and myself and other subject matter experts at NextFlex to help provide feedback, and we can provide guidance in terms of alignment with your proposal idea, with the topics, make recommendations in terms of potential partners and building a team. So strongly recommend those as part of the proposal process, but is not required. That leads up to the submission of the proposals. We'll talk about that a little bit later. But the proposals are due May 20th, and then we enter our peer review. So as with the topic development is really a NextFlex member-driven process where the members identify the technical challenges, help develop topics. They will be the ones that review the proposals. So the members, as well as government partners, tech council members, NextFlex staff, government subject matter experts all go together to review the proposals, provide scoring and feedback to the technical and governing councils for ultimately project selection, which we expect to take place this July. So in terms of those key dates, I have a list here that's reproduced from the guidebook. The most important upcoming dates would be the online cover sheet submission date of May 13th. So those cover sheets are due 1 week before the full technical proposals. Those have preliminary information in terms of who the proposers are, what topic you're proposing to, who are all the team partners. And those are mostly meant for us to be able to identify and start coordinating who are going to review the proposals, how many proposals we expect for each topic. So we do require that 1 week before proposal submission. Proposals themselves are due on May 20th. As I mentioned, both of those submissions will be done through a form stack link that is in the guidebook. Hopefully a very straightforward process in terms of completing a form, uploading your documents, and sending the proposal documents. We will then enter our review process, which I mentioned, and are tentatively expecting technical council and governing council review and selection of proposals by late July. I will note we do expect a second part of Project Call 11. This year is a little bit different. We made the determination to split Project Call 11 into 2 parts due to the availability and timing of funding. So we do fully expect a second part of Project Call 11 with additional topics to these. So these topics will receive proposals, we'll make determinations on funding. There'll be a separate set of topics. We expect later this year, depending on the availability and timing of funding, but we fully expect to launch a second part of Project Call 11 later this year. So I want to make everyone aware of that now. So because this first part does have fewer topics than we typically do in a traditional project call. I already mentioned sort of the process of the topic development. It was really derived directly from our technical working group roadmap, the gap analysis that we perform, looking across the technical working groups on priorities so we can efficiently make sure to address those real large cross-cutting barriers that are preventing adoption, broader adoption of hybrid electronics. That's the process. Key technical themes that align with the topics that were ultimately selected in this part of the project call. Really looking at improving manufacturability, reliability, into qualification, improving yield, demonstrating confidence in performance really at scale. So showing the maturity of a lot of these manufacturing processes. It's no longer, can you manufacture something this way? It's more, how do we continue to scale it? How do we continue to improve yield, demonstrate that manufacturability, and work towards qualification, certification, transition of those technologies. We discussed throughout the technical working group member meeting process the need for standardized shareable data on materials, process, reliability, and performance across these different processes or technologies in hybrid electronics. A big emphasis, not just in this project call, but across the DoD right now is demonstrating capabilities for sustainment, inspection, repair of platforms, specifically repair of electronics, but also how do we sustain, how do we maintain various platforms, how do we utilize hybrid electronics to be able to do that faster, lower cost, improve sensitivity, improve readiness for the defense industrial base, but also the organic industrial base within the Department of Defense of those that inside of the agency are responsible for sustaining and maintaining these platforms. And finally, development of application-specific qualification pathways and certification frameworks. So again, given the relative maturity of several of these technologies, demonstrating qualification, certification against application-specific standards, requirements, so we continue to de-risk technologies for adoption. The topics themselves are quite similar in structure to the last several project calls. They are open. They have a description that describes the requirements, but they're a little bit, I would say, more bound than in the couple of years past. We still want to keep them open. We don't want to we want to make sure to broaden the group of solutions, potential solutions that are proposed. We don't want to, show any perceived favoritism towards one technology or another. We want to keep that open and not have a prescribed solution to our challenges. But this, because we did such a robust remapping and reorganization and refinement of our technical gaps through this road mapping process, we want to make sure that we are really highlighting those key technical gaps directly from the roadmaps to the topics themselves. So I'll talk a little bit more about that when we get to the topics, but they essentially combine a broad description and objective of what the topic seeks to address, and then has specific broad sort of generalized lists of technical gaps that we'd like to address with each of those topics. So more details on that in a couple slides. We plan to use examples to reference in terms of those specific roadmap gaps themselves, those technical needs, and maintain traceability of those gaps through review of the proposals, project selection, execution of those projects, where we want to make sure that we are addressing the gaps that we intended to when we put the topics together and when proposal projects were selected. Other important considerations, this is a lot of text, but we want to make sure to be able to utilize this presentation along with the guidebook as a reference for all the important information. So we do anticipate funding one project in each topic area. This is subject to the projects that we receive, the total costs of the proposals, the top proposals that are identified, and the overall quality of the projects that we receive. But we do, with this initial part, 3 topics, have the funding to fund 3 projects and intend to fund 1 in each of those topics. There is a clear focus for the projects to have near-term commercial impact and transition potential. So teams that are industry-led or have a strong industry partner as part of that commercialization plan are more favorably considered in the evaluation process. That's not to say we don't fund projects that are university-led, and I think every project call we've funded projects that are university-led, but we do call out, because the perception that we're going to have more near-term direct commercial impact if it's a project's being led by a commercial entity. There is preference for those projects. We do also strongly encourage engagement from DoD stakeholders. I would say especially for topic 11.2, if you've looked at the topics already, and in demonstrating that example of DoD engagement. So that would be through a memorandum of understanding, co-development agreement with the service lab, representatives letter of support or similar from a representative of a portfolio acquisition executive or program executive office, or partners within the organic industrial base, really demonstrating that pool of the technology within the Defense Department can go a long way in strengthening the transition story and potential for your technology and your proposal. So I also want to call out the proposals that fall within topic areas defined by the updated DoD critical technology areas, and there's links to the updated websites within the guidebook, or other priorities of the Department of Defense will be given preference. So look at those critical technology areas, as well as justify other priorities of the Department of Defense, and that will strengthen your proposal. I will note that prior to final awards, recipients and development partners who are not already NextFlex tiered members are required to become Institute members, and will have to execute a development agreement before the project can start. So it does not factor into the review process if you are a NextFlex member, but if your project is selected, you would need to become a member at least tier 3 to be a lead or a development partner on any of the projects that are selected. And should the teams, I think I already sort of mentioned that, but if the topics in these first 3 topics of Project Call 11, we fully expect to launch a second part later this year. If they don't align with what you believe are priorities for the industrial base to advance hybrid electronics, let us know. If you're a NextFlex member, we encourage you to get involved with the technical working groups to have your voice heard in that mechanism. But if you have ideas for future Project Call technical themes, topics, please let us know. So the call itself, 1.9 million in total NextFlex funds, which would equate to right around or greater than $4 million in total project value when we include the cost share. So all of the projects do require at least a one-to-one cost share requirement, which I'll talk about, I believe, in the next slide. In terms of NextFlex funding, broken down by topic, two of the topics have a maximum of $500,000 of NextFlex funds available. 11.2 has $900,000 in project funds available. A change that I want to make sure to highlight in this Proposers Day upfront is the maximum duration for all projects within this first part of Project Call 11 is limited to 15 months. So we are strongly encouraging aggressive timelines, both in contracting to get the projects that are selected under contract very quickly, but also being realistic in terms of time to execute the work, because we do not anticipate there will not be availability for extensions, no cost extensions on these projects. And the reason for that is just contracting timelines in terms of our cooperative agreement, getting these projects completed by the end of our second cooperative agreement, that these projects will be contracted under. That's essentially a statutory requirement. So just want to make that clear that these are slightly condensed in terms of 15-month period of performance. So let's get the projects that are selected contracted and executed quickly. We're happy to work with all of the teams that are selected to make sure that we hit those marks. Finally, proposals that build on or take advantage of previous project call projects where appropriate are encouraged, as well as those that utilize the best technology available. So it's not a requirement to build on previous project calls. We always encourage that. Even if you weren't the lead developer of that in a previous project call, utilizing that work and leveraging that work is always recommended. So I already mentioned at least a one-to-one cost share, or 50% of each of the total costs of the projects has to be represented by cost share. I should note that this is for the entire proposal team. It is not by individual member of the team. It's up to your proposal team to determine the allocation ratio of cost share across the team, but the total budget has to be at least one-to-one cost share from the team itself. We share a document on the PC11 website that describes what we can legally constitute as cost share in the project. So that can include labor, materials, use of equipment, travel, cash, but it has a legal definition under the uniform guidance of what can be utilized as cost share. And if you have any questions throughout the process, we're happy to answer those. I already mentioned that any recipient of funds executed under the development agreement for a project must be at least a tier 3 NextFlex member. Includes subrecipients. It does not include suppliers, material suppliers, but it does include all development partners. So it does not include companies supplying COTS parts on projects. And federal government agencies, so government partners, service labs, FFRDCs cannot receive NextFlex funding. We do encourage their participation if they're willing to self-fund part of their effort on a project because they're highly interested in the result and the technology development. That's highly encouraged, but we cannot transfer agency funds to another part of the agency, or basically can't fund another part of the federal government using these funds. So be aware of that. In terms of the projects and objectives and deliverables, so reliability and standards really cut across all topics. They're called out in specific areas, but they're mentioned in the overall guidebook themselves. But keep in mind, for each topic, we really want to be able to demonstrate reliability, use of existing standards, calling out gaps where standards for printed or hybrid electronics might not currently exist. All of those are of high interest throughout in the proposal. We call out that projects that focus on process development. So those that are really looking at developing maturing manufacturing processes, we really ask for high level of documentation. So those, when we share that information across the NextFlex membership, that those can be reproduced with high accuracy. So that includes, I'm not going to go through this whole list, it's included in the guidebook, but data, both raw and processed, on the materials used, the process, equipment, what resultant performance, how that was characterized, what the reliability testing looks like. That reporting out quarterly in technical reports, as well as the webinars for the NextFlex members, is very valuable, and that's what we're looking for in those types of projects. Includes flowcharts, justification for test and measurement for TRL and MRL advancements, identification of those specific tasks within your proposal of how you're going to work towards TRL and MRL advancements specifically. Cost models are very important in terms of manufacturing techniques and sharing that information with our membership. Those are very valuable as well. And sort of relevant processing information, not going to go through this, but really all the nitty gritty in terms of details of resolution, line thickness, properties that are using, again, how you characterize the performance, tolerances, all of those deep technical manufacturing development metrics should be captured and shared. That's really the value of the Institute in terms of sharing all of this pre-competitive development information with the industrial base in our Institute to further advance the technology more quickly is really one of the key deliverables. In terms of hardware deliverables for all projects, we do request physical deliverables for all projects. So even if it's a project that's really focused on process development, having those test coupons themselves as physical deliverables are very valuable in terms of the NextFlex Institute and being able to promote the project and sharing with other members or government partners or agencies that might be interested, but also providing those to the community in forms of new materials, platform demonstrators, which I'll talk about. But having those physical deliverables, that the data that I already talked about, highly valuable, but having a physical deliverable for projects, whether it be test coupons, articles, a demonstrator, are also very valuable. So the platform demonstrators themselves, so we have language in the guidebook, please reference it. This is more specifically to topic 11.2, which I'll cover, but we describe a platform demonstrator as something that really showcases a novel technology solution, and it clearly illustrates the value proposition of utilizing hybrid electronics manufacturing approaches. And I'll say clearly illustrates maybe to someone that's not highly skilled in the art of specifically hybrid electronics, but they really can see the value of a technology or an article through that demonstration. So NextFlex, the Institutes broadly cannot fund product development, but what we're really looking for in a platform demonstrator is a product-like functional demonstrator. So if you need packaging, if you need firmware to run it, if you need something that makes it a little bit more polished as a functional demonstrator to show off a capability that looks more like a product, that's really what we're looking for, not something that looks more maybe like a lab curiosity in terms of having lead sets to a open battery, and those can be helpful prototyping developments, but in terms of a demonstrator deliverable for a demonstrator topic, we're looking for a platform demonstrator that looks much more polished and comprehensive to showcase the capabilities of the technology. So those are strongly encouraged. We do have the NextFlex developed microcontroller platform shown in the rendering shown in the image here on the right that we call A21. That is a microcontroller platform that's available to NextFlex members so that we can provide the specifications, the design for that. That is the basis of a number of projects that we've done over the last several years internally at NextFlex and as part of agency-driven projects. We've made that available to members to build on as well. So that can be a fantastic platform to build a potential platform demonstrator from, and reach out to us at proposal@nextflex.us if you want additional information on that. Happy to provide information on that as a potential source of a starting point for some of these platform demonstrator projects. We're also strongly encouraging proposers for the demonstrators especially, but for all projects, to provide throughout the project images, videos of these demonstrators functioning. If you do, I don't know, a flight test of, say, a drone, having that documented in a professional way is very valuable as another type of deliverable in terms of projects. All right, I'm gonna now go into the 3 topic descriptions themselves. I'm going to, at a very high level, describe what their objectives are. Please reference the full topic description within the guidebook in terms of the requirements, what specific examples, subtopics, the technical areas of focus that each of those topics have. If you have any questions of that, that's a perfect thing to discuss during a pre-submission consultation, or send us an email. Happy to answer those questions. So mentioned several times, there are 3 topics. The first 2 topics, 11.1 and 11.2, are funded from a different set of funding directly from the Office of Secretary of Defense, the Mantech office, specifically focused on installation resiliency and efficiency. So that's where the main theme of this project call comes from. Two projects utilizing that funding. The first is resilient manufacturing of hybrid electronics and printed circuit boards. So looking at developing and maturing manufacturing approaches. That has a maximum funding of $500,000. The second is a demonstrator topic, demonstration of hybrid electronics for installation, resiliency, and efficiency. That one has a $900,000 maximum of institute funding available. So that is before the cost share. That is the amount of federal dollars available. The third is 11.3. That is funded from the type of funding that's more traditionally funded to project calls. That is a topic that really came out of this road mapping discussion through the technical working groups over the last 6 months. That is focused on utilization of AI and ML enabled materials and process data infrastructure for hybrid electronics. So I'll get into those topics next. Just wanted to bring up this figure that shows, again, the duration for all of these is going to be a maximum of 15 months. It also shows our accounting in terms of alignment, both direct and indirect, for the technical working groups. And that's more, I would say, robust in terms of this cycle. We now have tables of what specific technical gaps we would like to be able to address with each of these topics. And we'll be doing those, continuing to track those metrics and do that accounting throughout the process and projects execution themselves. So again, we do expect to fund 3 total projects, 1 project in each of these topics in this first part of Project Call 11. So I already mentioned this. I want to hit on a couple of very specific points that the topics themselves are really meant to address the prioritized gaps on the roadmaps. So those outcomes are really meant to have the largest cross-cutting impact, both in the commercial and defense sectors and across the U.S. Hybrid electronics industrial base. So the structure of the topics, each of them have a couple of short paragraphs after the topic title. Those are really the requirements. Those are sort of the broad objectives that are required for each proposal that we receive in those topics. We then have subtopics, 3 or 4 bullets within each of those topics that are meant to be examples, but are really subtopics that we're looking to get proposals against. So we can talk specifically when I go through those over the next slide, but those are really subtopic areas that we intend to receive proposals. Each one of those has another bullet list of 4 or 5 Roman numeraled indexed generalized gaps that directly align to specific gaps on our technical roadmaps. So we're really trying to reiterate that addressing at least 1 or more of those within a topic is what we're looking for in a proposal, to clearly lay out, here's the technical area that's identified in the topic. Here's how I'm going to address it within this project. Here's how it's, why we are, as an organization or a proposal team, is interested in it. But here's why it's valuable and beneficial to the industrial base and the NextFlex community. That's really what we're looking for, that justification, that description in those proposals. So I will say, alternative approaches that we might not be thinking of are that might be within scope of the requirements within the topic, but are well justified within the proposal will also be considered. But those subtopics are the high priority areas that we're looking to receive proposals against. So happy to answer questions on that, especially, as the proposals are developed and we have pre-submission calls and questions that come in. So topic 11.1, I mentioned this is really looking at maturing and advancing manufacturing approaches, and specifically for hybrid electronics. So manufacturing of hybrid electronics articles using additive approaches, but also how do those techniques complement or supplant potentially aspects of more traditional electronics manufacturing, specifically printed circuit boards. So there are opportunities to adopt additive approaches, materials, specifically into a traditional PCB manufacturing workflow to reduce the number of steps, reduce material waste, improve yield, reduce variability, increase form factor capability. All of those are within scope in terms of this project. So how do we further mature these hybrid electronics approaches, and then how do we look towards transitioning them into manufacturing flows, whether it be hybrid electronics or complementing traditional electronics manufacturing, and how do we do that at scale and at higher yield? So working with manufacturing partners, looking to modernize manufacturing, expanding capabilities of the DoD, specifically the organic industrial base, are all of high interest. So this is a topic where description of all that data generation, sharing of that data, is highly valuable. There's some common language across all three topics that describes what I did on the last slide, where there's 3 examples in topic 11.1 that are directly derived from our roadmaps. Successful proposals will prioritize one of these areas, directly address cross-cutting barriers limiting scalable adoption of hybrid electronics, and demonstrate clear and measurable impact not only to the proposing organizations, but the broader industrial base. So the subtopics included in 11.1 are additive and hybrid fabrication workflows for PCB and hybrid electronics production. Basically what I described in terms of improving those process flows, utilizing additive and hybrid electronics workflows. The second is biomanufactured and bio-based materials for circuit manufacturing. So how can we utilize newer, greener sourced, biomanufactured, bio-based materials, inks, to reduce impact of material use, reduce waste through circuit manufacturing, whether it be hybrid electronic circuits or traditional PCB circuits. And then finally, recycling, upcycling, and waste stream reduction in circuit manufacturing. How do we recycle existing circuits? How do we upcycle, do things like repair and reutilization of components or circuitry? And how do we reduce waste stream production in those processes? So that is topic 11.1. A lot more detail in the guidebook, so please go to the guidebook. Each one of those ABC bullets have 3, 4, or 5 specific technical areas that are derived directly from our roadmaps and generalized in the guidebook that show what technically we would like to address with each of those topic areas. So take a look at those. Topic 11.2. So this is our demonstrator topic, looking for how do we implement hybrid electronics for installation, resiliency, and efficiency. So there's some language I've reproduced here from the guidebook, which I've already talked about, describing what a platform demonstrator, what the expectations for that are, the availability of the NextFlex A21 microcontroller device as the potential platform to leverage to build a platform demonstrator, and the strong encouragement and strong preference for proposals for this topic that engage DoD stakeholders. Because of the source of the funding for this topic, because of the interest in demonstrating capabilities and advantages to hybrid electronics, specifically for DoD use cases, we're really looking for engagement through evidence of engagement through an MOU, strong letters of support, co-development partners and service labs, working with PAEs or PEOs. Those are strongly preferred in this topic, specifically to demonstrate DoD benefit and DoD readiness and resiliency and efficiency improvements. So I've covered a lot of the topic description. Just want to emphasize this is about demonstrating capabilities from a technology. So how can we lower lifecycle costs? How can we improve readiness, improve inspection timelines or operation timelines, or improve logistics within DoD installations? If we're doing maintenance, logistics, we're looking to improve the overall execution of the mission. That's what this project is really looking to demonstrate. And projects should clearly articulate the use case, because there's a broad range of applications, but tracking those metrics and those benefits of tool availability or asset availability, inspection cycle time, logistics, resiliency, all of those are what we're looking to demonstrate and demonstrate that impact by utilizing these technologies. So the 4 that are included in topic 11.2 are sustainment, inspection, and repair technologies. So that's where how can we support the defense industrial base and the organic industrial base through these adoption of these technologies to improve all of those areas. The second one is autonomous and intelligent systems. How can we demonstrate improved mission resiliency and efficiency through novel approaches, through utilization of unmanned aerial systems or other autonomous platforms that really showcase the size, weight, and power benefit of a lot of these technologies? How can we demonstrate impact, show great reduction in cost for some of these applications, flexibility in terms of design, form factor, lightweighting, all of those for specifically autonomous and intelligent systems for DoD improvement, mission improvement. The third is low cost Internet of Things devices for logistics and supply chain visibility. How do we improve logistics by adopting IoT devices that are manufactured through hybrid electronic processes? There's more language describing this in the guidebook, but I'll note that there are IoT solutions out there. There have been IoT technologies being developed in previous NextFlex projects. We describe in the guidebook, this is less of demonstrating that a capability of an IoT device is possible, but showing how can you operationalize it and really deliver that impact that these depots or these maintenance facilities are really looking to be able to execute, these logistics facilities. So how do you operationalize it? Not how just you demonstrate that one node of a network is possible and can provide real-time data. It's how can we work towards operationalizing that and getting that out in the field more quickly. And the final one is asset structural health and structural health monitoring. So how do we incorporate sensing into assets, whether it be a small tool or a large airframe? How do we do the same for structural elements, infrastructure, bridges, other platforms? How do we maintain monitoring? Similarly to the IoT devices for logistics, the focus of this one, the intent of this subtopic is less on can we showcase that you can integrate sensors and demonstrate that sensing is possible, we can get data off of these. It's really more focused on application-driven qualification certification requirements. So how do we show that not it's possible, but here's how we continue to mature it and de-risk it for adoption into a specific application. So if that's a airborne platform, that's for space, if that's for ground vehicles, if it's for man portable, if it's for a maintenance facility, all of those use cases are going to have very different requirements. So making sure to align the qualification certification requirements with mil specs and standards specific to the application designed for the proposal is really what we're looking for there. So that's 11.2, demonstrating capabilities to improve impact and demonstrate in the installation resiliency and efficiency realm. The last one, topic 11.3, this is AI and ML enabled materials and process data infrastructure for hybrid electronics. This has a $500,000 maximum and again 15-month period of performance. This, and I mentioned earlier, came out of a number of conversations we've had over the last several months and a couple of years actually, of how do we better leverage the knowledge base and the data that have been developed over the last decade of project call projects, through the technical reports, through the webinars that are given quarterly. How do we leverage that data more efficiently, and how do we make that a more valuable resource for the industrial base? So given the advancement of artificial intelligence and machine learning tools, we believe we're at a point where we can more quickly leverage that to parse the data that we have, generate databases that are usable, implement tools on top of that database that can more quickly get us information that the industrial base needs to more quickly select materials, do process development, do testing, make sure that we can more quickly leverage and share that knowledge base that we've been generating over a decade. So one caveat to that is that data security and intellectual property rights are incredibly imperative in all of this process. So we do ask that proposers to this project work directly with NextFlex, so we can make sure that during the proposal development phase, we can continue to make sure that what you're proposing aligns with what are the requirements under our cooperative agreement and development agreements and the IP policies across the institute. So heavily encouraged there. So in terms of the subtopics where we're looking for solutions and we're looking for proposals, the first is how we can leverage existing AI and ML tools to parse the data that lives now in static technical reports and slide decks and webinars. And how do we utilize that to build a useful data structure to start putting a database together? So we have projects in all different technical areas that have different reporting. It's very non-standardized data at this point. How do we leverage these tools to more quickly get to a point where we can parse and develop schemas and build that database? How can we leverage tools out there? And we're looking for solutions in that area. The second is materials and process database architecture development. So once we have the idea of how we want to put that database together, how do we actually execute establishing that database? How do we do that in a way that is possible in terms of our requirements, as well as how do we make it as user-friendly as we can for our members and our government partners to be able to utilize? And the third is how do we continue to ensure data security? How do we maintain governance on that? How do we limit access control? How do we actually implement that framework? And how do we do that in a cost-effective way? And thinking more long-term of once we put this together, how do we continue to keep it operational and continue to put new data into it and make it a valuable resource for the members and government partners of the Institute? So those are the three topics. I want to close out by describing the evaluation criteria. The same process we've used for the PC process for several years now. I already mentioned the reviewers will come from NextFlex members, government subject matter experts, NextFlex staff. There are rare occasions where we engage other persons under NDA or under the participation agreement to review as a third-party subject matter expert. So that's an option that we can utilize as well. But again, this is a member-driven process. So we want the feedback from the members and our government partners of where they see the biggest value in funding the projects and getting numerical scoring as well as feedback and comments. So we have evaluation criteria, which I'll cover on the next couple of slides. We get scorecards back from those reviewers that have numerical scores and those comments. We then analyze those and provide those to our technical council and our governing council to make a recommendation and ultimate selection of the projects that get funded. Here's a example of the scorecard. This is in your guidebook in one of the appendices. Difficult to read up here, but we provide the scorecard that the reviewers will be using, as well as the 14 criteria and the explanation of each one of what the reviewers will be looking for in the proposals. So I think I explained this on the next slide, but those 14 criteria are split into two different sections. So technical merit and transition potential criteria and non-technical criteria. So those first 8 criteria are what we use to determine the technical score numerically. And then we have also a non-technical score. From that technical score, we develop a ranking. So we rank in terms of technical score, the proposals within each topic. And then we heavily utilize that technical score as well as the comments that we receive. That non-technical score is very helpful when we look at 2 or 3 proposals that are very close together in technical score and ranking. Look for those as differentiators or to identify potential outliers in the proposal process. So keep in mind, we do a very robust analysis of the numerical scoring. We review all of the reviewer comments that we get back and have discussions with the reviewer sets themselves. If we need more clarity on specific comments or why something was scored the way it was, and we take all of that to our technical council to have a robust conversation as well as our governing council. So that's the process that we go through. The governing council will ultimately consider the reviews, the numerical and comments, the technical council comments and recommendation, other factors such as the alignment with NextFlex's dual mission to promote U.S. manufacturing and hybrid electronics and support DoD technology transition, ultimately to balance the project portfolio. I don't think I mentioned it, maybe I skipped over it. I will mention that NextFlex members are, actually I have it on this slide. NextFlex members are the reviewers, but we also are very mindful of eliminating any potential conflicts of interest that we identify. So a reviewer from an organization, so if an organization has submitted a proposal to that topic, there can't be any reviewers from that organization. So that's one way that we eliminate potential conflicts. We also ask any reviewers at the time of distributing the proposal, if there's any conflict of interest, they might be working with an organization on another project and might not feel comfortable to review that process, just let us know. We do our best to eliminate any potential conflicts of interest as they might arise. So my last slide here, I'm going to go ahead and start calling for reviewers. So if you're a NextFlex member, if you're a government partner, you can go ahead and start enlisting yourself in terms of being a reviewer for these 3 topics. It's vitally important that this process has strong membership representation and government partner representation. So we make sure that we are funding the projects that will have the biggest benefit to the industrial base. So it's a benefit of NextFlex membership to be able to serve as a reviewer. Please do so. It's very helpful to us. Please recruit others from your organization to serve as well. So we balance it. We also limit it to 1 reviewer from each organization for each topic. So we don't want to overweight it one way or another in an organization. We also like to have multiple government reviewers on each topic within reason. We want to make it nice and balanced, and we look at the ratios across industry, academic, NextFlex, and government reviewers for each proposal and each topic. So we want to keep that balanced as well. So we do ask that all reviewers are familiar with NextFlex, the goals of NextFlex and the Institute, and hybrid electronics in general in a particular topic. So you can go to this form stack and you can scan the QR code now. You can go to the link when we send out the document on the PC, or when the document's posted on Project Call 11 website. But please go ahead and register to become a reviewer for this part of Project Call 11 now. So that's basically it. This is for this portion. We're happy to take any questions that you might have. This might be a little bit out of date in terms of what your GoToWebinar interface looks like, but you can go ahead and enter any questions you might have for Scott or myself in the window pane now. You can also raise your hand and you'll be unmuted and be able to ask your question, or if neither of those work and you can't figure out how to do those, you can also send an email to marcom@nextflex.us. While you're preparing those questions, I think I'll go back, but I'm going to go ahead and put this up where after today, if you have any questions at all about the project call process, proposal@nextflex.us is your best source. As Scott called out, you'll get the quickest reply that way because it goes to a number of us here at NextFlex. So I will open the floor to any questions. Let's see. Jessica, do you know if there are any questions? It looks like, I don't know when this question came in, but we had how many projects will we funded? We intend to fund 1 project per topic, so 3 total projects are expected to be funding. That depends on what proposals come in at in terms of funding requested, the balance of proposals that we get, the quality overall. But we intend to fund 3 projects in this part of Project Call 11. Let's see, we have a question from John Lee. What are the capabilities of the Technology Hub in San Jose available to a proposing group, assuming NextFlex membership, and what are budgeting implications for such usage? So we do like to discuss this. It is an option to utilize the Technology Hub in San Jose for a small part of these projects. We do not take funding out of the budget for a project call for a reasonable effort. We don't like to take the funding for the project calls and divert it into the staff to do work at the technology hub. But we are there to support projects. So if it's, a small part of, doing a little bit of process development or trying a process on a piece of equipment, we're happy to do that. There's a number of options, but I think in the guidebook and what we recommend is just reach out to us and discuss what you're looking for, and we can either share what the NextFlex Technology Hub could potentially provide, or recommend another partner among our industrial base that we know that might be able to be a better partner and provide you with the capability you're looking for. Hopefully that answers.
I'll add just a couple of maybe a couple of additional thoughts there. To give you an idea of the kind of the scale of support that we can provide, we budget a fraction of a full-time equivalent across the entirety of the project call. And so, it's not meant to be like a major team partner, but certainly we can contribute strategically in places of importance. You could consider things like process, an element of process development, maybe a little bit of fabrication, some design consulting support, a lot of capabilities. And that's where, as Nick said, having that conversation as part of the pre-submission consultation is so valuable. The other piece that I would suggest to all of you is that if there are opportunities to take some of the process technologies that you've developed within a project call, or that you're aiming to develop within a project call proposal, and transition that to the technology hub, that would be another great way to assist with the technology transition, to make a capability more available across the ecosystem, and to engage the technology hub all at once.
Yep. Thank you, Scott. Looks like we have another question of if we're going to share the list of participants of this webinar and whether they showed interest in looking for a team member. It's a good question. I don't know if we can share the list of participants. I don't know if we've asked if they're willing to share that they've registered for this, but what we do is encourage for the teaming event part that we're entering in after Q&A is for those that are interested to raise their hand and say they are leading a team or they would like to join a team, and for you to directly reach out to them. So that's an opportunity for those that are looking to build their team to do so. Maybe we can discuss another option internally about how we can make available those that are interested, or maybe set up a list of those that might be interested in joining a team outside of the teaming event. Let's see. So who do we contact about getting a NextFlex a flexible microcontroller device for evaluation? Proposal at nextflex.us. Steve, that would be the best route to do to provide information, and we can have that discussion. I don't know if I missed anything. Any other questions? Any hands raised?
There's one more question, Nick.
Yeah, could you please elaborate more on the difference between product development and product-like demonstration? So there's language in the guidebook to do that. Scott, I don't know if maybe you provide your perspective on that. I sort of already shared mine.
Yeah, sure. So the way I think about it is the work that is done through project calls is inherently meant to be pre-competitive. And so if you were to do product development, within a project call activity, you would be required to share all of the details of that work that you're doing, including all of kind of the secret sauce, the things that make your product special. That would be competitive advantage in a marketplace. And so that's not something that most companies would want to do, to share all of that information. So the idea is that rather than developing the product itself, develop something that demonstrates all of the important capabilities that enable you to make the product. Something that you would take as an initial prototype and take that into a product development process to turn it into the actual product that you would use to go to market. Making sure that you can evaluate as many of those important attributes or process capabilities, whatever the right element is for your project within the project call, but without actually being the final form that you would have when you go to market. It's something we can delve into a lot more specifically in the pre-submission consultations as well, without having to speak in real generalities. That makes it really difficult.
Thank you, Scott. If there aren't any other questions, we'll go ahead and move to the teaming event portion. Again, I'm going to throw this back up. If you have any questions throughout this whole process, proposal at nextflex.us is going to get you the quickest answer. And go ahead and volunteer to be a reviewer. All right, so let's move into the teaming event portion. So for this, so the structure of this event, we have 3 topics. We're going to progress through each of them sequentially. We have a bit of a catch-all at the beginning for if someone that submitted a slide didn't express which topic they'd be interested in participating in, or they sort of picked all of them. We put that on the front end in terms of broad interest in participating. But each proposer that sent in a slide will be allowed that single slide and try to keep it to 2 minutes to pitch their proposal idea, their capabilities, what they're looking for in terms of partnership. And then they each should have their contact information on the slide. If they don't, we can add that later and make sure that people get connected. But really, the intent is for all of you to reach out directly to those members if you have additional questions, or if you'd like to discuss a collaboration opportunity with those individuals. So we have 2 overall slides, 6 for topic 11.1 and 5 for topic 11.2. So I believe they will be in this order. So I will pause for a second here while you take a look to see where you sit in the ranking. So University of Delaware, Nathan, I don't know if you're on, you will be up first. You should be given the availability to unmute yourself when it's your turn, and Jessica will grant that. And we will progress through all of these. If you haven't submitted a slide and you have one ready, you might be able to send it to marcom@nextflex.us very quickly, and we might be able to tag it on at the end. But
Or if you believe you've submitted a slide and you don't see your organization listed here, you can let us know in the chat ask us a question through the question pane, and we'll try to get that resolved.
And maybe I'll add, if you don't have a slide, but you want to express that you have interest, you can go ahead and throw it in the chat as well, and maybe you can just connect offline. So first, these are organizations that have broad interests across the project called topics, and we will start with University of Delaware. So
actually, it's going to be me. I'm Xiaoming. Layson is in Texas for invited to talk, so I will present on behalf of both of us.
Perfect. Glad to have you.
Great. So hello, everyone. So I'm Xiaoming Li from University of Delaware. Layson Nazareth and I are developing AI-powered tool that cover the full design, simulate, fabricate pipeline for hybrid electronics. And we are looking for partners to bring this to real-world applications. Our core AI capabilities span 3 areas you see across slides. On the fabrication side, we have multi-material direct write capability with unscripted printers, so that we can do conductive, insulating, and functional inks. So we can go from a digital design to a physical device in-house. Let's look at the first AI capability, that's LLM-driven EM CAD. Starting on the left, we use large language models to generate a 3D printable electromagnetic component from natural language descriptions. But here is the key insight from us. Generic LLMs fall short. You can't just prompt, for example, ChatGPT and get a working EM component. As the architecture diagram shows, we had to build a specialized multi-module agent, a parametric CAD generator with geometry constraint, a meshing engine for conformal boundaries, and a physics solver, all AI generated, but requiring careful domain knowledge and interactive refinement. The evolution on the right shows the result that we built from an initial 3D model through progressive refined designs and the training of the LM agent, and we finally reaching the design goals, all without commercial CAD software. Let's move on to this column in the middle, that is multi-constraint EM optimization. The middle column goes beyond EM-only design. That is, we look at the real hybrid electronics needed to be strong, lightweight, and manufacturable, not just electrically correct. What we do is that we use AI-generated algorithms, including discrete element method packing, centroid Voronoi tensilization, and the TPM lattices to co-optimize across all these constraints. You can see the working flow here. That we start from a density, and this is an example working flow. We start from a density field to define the functional feature, which are converted into printable geometry. But this printable geometry cannot be manufactured independently. This geometry needs a substrate, which is regenerated and then strength optimized through DAM simulation. The result is a combined product, as you see on the bottom right, that is actually printed product. That is a combined product ready for multi-material printing. If we move on to the column 3, that on the right, that is our work on simulation-guided design and verification. AI, in our work, we don't just limit AI to design tasks. We also use AI to generate a simulation code to validate AI's own designs. For each new geometry, AI produces a customer voxel-based solver that predict electromagnetic and also electric metrics such as resistance, capacitance, and structural properties before we print anything. This close a loop that design, simulate, verify, and iterate, or go straight to fabrication with confidence. We want to highlight that is building these solvers manually for every new design would be infeasible in the traditional working flow sense. That is, it's involved too much work iteratively, but AI make this working flow routine and highly repeatable. So as a close thought, so all these capabilities align with, we believe we align with PC 11.1 topics, and we are seeking partners in EM design, additive manufacturing, and also advanced material and DoD applications. So please come to talk to us, Nathan Nazareth and Xiaoming Li, we both from University of Dalville. Thank you.
Thank you so much, Xiaoming. All right, we'll move on to San Jose State University. See if we can unmute yourself. I don't know if Jason.
Hi there. I'm Jason Kim from San Jose State University. John Lee will actually be presenting on this slide. I just wanted to say hello to the group. Thank you for the presentation. And happy to act as an initial point of contact for the university and just help connect to faculty expertise at our university.
Perfect.
Thank you. All right, thank you. So, thanks to Scott and Nick, for this opportunity. And then I'm John Lee. I'm professor of mechanical engineering. Got some background in microfluidics, additive manufacturing, and mechanics of soft materials. And we don't have a specific proposal or single technology to pitch here, but are mainly here to let folks know about some resources and capabilities that we think might be very complementary to a larger effort that others here might be proposing. So in addition to Jason, Jason is our, as mentioned before, is manager of our research corporate partnerships. And we probably have one or more other colleagues. I think Ling Zhang was going to join us, and she has expertise in mechatronics and robotics. So over the years, we've been engaged in a variety of projects involving novel manufacturing processes and characterization and process optimization thereof. We've collaborated with both small companies and other universities. And they got, one example is over on the right is a photo of a flexible electrophoretic display that was done in partnership with Zycon in Sunnyvale. And so on the slide, we just threw together some of the examples of metrology and prototyping capabilities that we have. It's not an exhaustive list. There's quite a bit more. We have a microfabrication facility and a materials characterization center. The links are provided in the upper right-hand corner. And those websites are probably a bit outdated, right? But they'll give you a general idea of some of the capabilities we have. And today, especially I wanted to point out some things about our human resources and personnel. We have a wide variety of faculty with interest in partnered applied research. It really spans, I've listed just a couple of the keywords here, spanning process engineering, mechatronics, AI, feature recognition, defect detection, and otherwise. And so Jason, with with our structure here, he knows all of us. And if there is a project for any of these keywords that might jump out to anyone, if you just reach out to Jason, he'll know to contact the right faculty members. I think we're very proud of our teamwork here. It might be 2 or 3 individuals, right, that can potentially help larger proposed project ideas. And in addition, something about the way we work here is that we do have a pretty vibrant master's degree program, and kind of it fits inside that 15-month window. It's supposed to be 2-semester projects. And every semester we have a talent pool of, in mechanical engineering alone, there's not even speaking of the other departments, we've got about 30 master's degree candidates who are looking for interesting applied research projects. And we come up with them. You know, there's more supply than demand as far as individuals who are interested in engaging in current novel manufacturing. So if that might be a possibility, we have partnered those master's projects, with companies for different projects in the past too. So that model might be appealing. Please do reach out and let us know. So I'll keep it at that to keep it short.
Thank you, John. Thank you, Jason. All right. We're going to move on to those that expressed interest in PC 11.1, Resilient Manufacturing of Hybrid Electronics and Printed Circuit Boards. First up is from UDRI, Chris.
Hi, this is Allie Cox. I'll be presenting on behalf of Chris today. So Chris is actually our lead of our ultra-short pulse length laser ablation laboratory. Here we have laser technologies ranging from CW to femtosecond lasers, but today I wanted to focus on our femtosecond laser technology and its capabilities. What makes femtosecond lasers unique is that they can machine and remove material without inducing heat into the part, so it's an athermal process. So that allows us to do things like remove material from the head of a match without igniting it, or more importantly to probably the group here is removing coatings and materials without damaging the substrate beneath it. So you can see some examples, and what makes this really beneficial is we can really precisely remove coatings. So we've removed copper and nickel from polymer and lightweight substrates. So we can get really lightweight designs, but have the function and the precise coatings that we desire on those parts. And we have 15 plus lasers that are pretty flexible within the workstations that we developed. And this is unique to each application that we develop. So for an example, you can see that we've integrated a workstation with the femtosecond lasers and a multi-axis machining capability to machine an 8x8-inch cone. So we can remove not only on flat surfaces, but complex surfaces like the cone that you see. We don't believe we've nailed down the smallest feature size that is capable with this technology, but have demonstrated about 10 micron feature sizes that is capable either with coating removal or partnered with AJP technology to clean up any overspray that you have during the manufacturing process. So we've developed processes and we've also worked on integrating this into existing process workflows. So we are very flexible when it comes to TRL readiness, and we are looking for potential project partners that think that this technology can benefit them. So if you're interested, please reach out to Chris. I also have another slide coming up later that I'll be presenting on that has my contact information. Thanks.
Thank you, Allie. We'll move on to UT Austin.
Hi, can you hear me?
We can.
Hi, thank you so much. And we are in mechanical engineering and as well as Texas Material Institute at the UT Austin. So our goal has been pushing for that develop one hardware, one tools that can potentially manufacture the majority structural or functional components and for hybrid electronics. So this has been done that the capability has extended from mighty scales, from nano, micro, macroscopic level, and also cover different materials, metals, semiconductors, dielectric materials, or softer biomaterials, and also multiple mode. Not only we can synthesize materials in the system, but these synthetic materials, not as a suspended solution, but it can be, meanwhile, it can be printed on the substrate. And we can print in 2D or print into 3D in different architecture. And we can also do the same printing, but from individual components, from individual nanoscale colloidal structures to micro, even millimeter components onto the specific position on the board. And those are additive manufacturing approach, but we also developed the way to do subtractive. We do etching, not only through photochemical approach, but also from photophysical way to etching different materials from two-dimensional atomic layer structure and to metal dielectric thin films. And the resolution can be from a few hundred nanometer, even below 100 nanometer, to micro and millimeter scales. And so the next step we're looking forward is to look collaborators to form the design, characterization, verification in the full circle, and through automations of partners in industry to validate at least some of this capability into actual functional devices or components. Thank you.
Thank you, Yubing. All right, move on to Polly C.
Hi, so I'm Michael Sotzing. I'm a PhD candidate at Purdue University. And here I'm actually presenting some material that we're trying to commercialize as a part of PolyC. So Azion is our conductive inks brand. And we're trying to commercialize the copper conductive inks that we've made utilizing bio-based polymers that were developed at Purdue University and the University of Connecticut. And we utilize these proprietary bio-based binders and passivating materials to synthesize copper particles and formulate copper particle-based inks. So we actually have two inks right now that are either pressure-assisted or pressureless. From our chart there, we want to show that we're competitive on a conductivity normalized cost basis, but that we also have versatile processing characteristics. So we show that we have good processing temperatures, low processing times, and then we can do these in ambient atmospheres, which is of interest broadly. And I think of special interest for this project call of NextFlex is that we can integrate into a resilient manufacturing line in that we've demonstrated in situ mechanical recycling of the copper conductive phase. And the fact that our polymer binder phase is actually depolymerizable. So we would say that generally sintered composites present a difficult challenge in that they're hard to recycle, but they are also preferred for high conductivities. And in comparison, to unsintered or carbon-based composites, you can achieve a totally different level of conductivity, but you also have those troubles of recycling. So here we show that we can have good recyclability over multiple cycles at relatively low temperatures for that sintering processing temperature. And one thing to note here is that the conductive phase can generally account for up to 90% of the energy and environment intensity of an ink. So we want to show that conductive phase recycling is a exceptional challenge that can provide significant enhancements in the resilient manufacturing space, and that we can do this while maintaining conductivity and other properties of other inks on the market. And so we've shown that these inks can be used for real applications on the lab scale. So by screen printing things like RFID devices or Joule heating devices, we can actually do that in situ recycling process in order to make new devices to address recycling or upcycling of circuitry that's been deposited. And we also demonstrate some nice to have characteristics such as solderability due to our proprietary antioxidant bio-based materials. So for this, we're looking for industry partners that can really take the technology from the lab scale demonstration to more line scale processes.
Thank you, Michael. Move on to Flying Wire. Mike, are you on? You might still be muted. Mike, are you there? Let's see it. Mike's got his hand up.
Let's try that. Can you hear me now?
Yep. Yeah,
Apologies for that. Okay. Too many audio in and out. So good morning or good afternoon, depending on where you are. My name is Mike Filler. I'm currently a professor of chemical engineering at Georgia Tech and also co-founder of Flying Wire. Flying Wire is aiming to make microelectronics on demand. And so from an FHE perspective, we're a little upstream of what we've been discussing so far, where we think we have a platform to create bare die. One of the big limiters with a lot of FHE is having to use other people's die or the NRE associated with making your own. So if we could open up the ability to make bare die specifically for FHE with interfaces that work for integration on flexible and otherwise FHE relevant substrates, that could be a big unlock. We take microscale computing elements. These are just shown as discrete transistors here. We turn them into suspensions, inks basically. They're deposited onto surfaces, imaged and wired on demand. And so the final step, since this is an FHE community, is done with electrohydrodynamic printing to get the near micron resolution that you see in that image. And the company is working to scale this technology. We're looking for partners who are more experienced on the integration, assembly, and packaging side of FHE to partner with, because we think this could be a really interesting path from more custom silicon to manufacturable FHE products.
Fantastic. Thank you, Mike.
Thanks.
Move on to Kent Displays. Donald, are you on?
He is not, Nick.
Okay. We'll move on to Pradeep.
Hi, my name is Pradeep Lal. I'm a professor at Auburn University. I also lead the Alabama node of NextFlex here at Auburn University. So the specific topic that we are proposing is on additively manufactured high-volume PCBs. And the intent in this particular topic is to build a team that would be focused on characterization of high-volume scale-up of additive processes and demonstrate Six Sigma quality at very high volume. So the intent is to seek partners that are conventional PCB makers that want to use additive methods for PCB fabrication. And at the bottom right are shown a couple of demonstrators that we developed for NASA on a prior program. These are 5-layer additive circuits that we demonstrated reliability of as well. But the intent is to really migrate out of lab scale processes to be able to show metrics that would allow scale up into a higher volume manufacturing capability that would be able to manufacture products and processes agnostic to the design itself, so to speak. So as a part of the program, we want to have partners that would actually help us in development of these adhesion metrics for inks on substrates. We have a number of test circuits that have been developed over the past several project calls for NextFlex, and we'll make those available to the team for measurement and characterization of the electrical stability across multiple sites. Identification of the process control parameters to be able to have repeatable batch-to-batch production, have uniformity, repeatability of the actual produced volume, and do that with assembled components. So pick-and-place machines and manufacturing process flows that are reflective of the actual assembly itself. So although we will partner with any of the companies within the nation, but if you are a company within the state of Alabama, we have some other things that we can perhaps make available to you. We are part of the Alabama node of NextFlex, and we would be able to make available local infrastructure that's installed on campus as a part of this particular program. And the intent is to really accelerate technology transition to be able to support the defense industrial base in support of much of the defense infrastructure within the state of Alabama and the nation. Thank you.
Thank you, Pradeep. All right, we'll now move on to topic 11.2, demonstration of hybrid electronics for installation resiliency and efficiency. All right, first up, we have Dr. Nick Ginga from University of Alabama in Huntsville. Nick, go ahead.
Hi, everybody. Yeah, like Nick said, I'm assistant professor in mechanical and aerospace engineering at the University of Alabama in Huntsville. The work in my lab, we're mostly doing mechanical characterization and coupled mechanical electrical modeling of materials. And I thought 11.1, 11.2 applied to some of the things that we do in our lab currently. We specifically developed a couple different mechanical characterization techniques that are kind of geared towards stretchable and flexible electronics. Number one we have there is our radial stretcher in the top right corner, where it's designed for stretchable electronics to test materials and test devices. In uniaxial or also multi-direction stretching. This machine can work in monotonic configurations and also fatigue configurations. So any materials or any devices, we can test the demonstrator that's stretchable in this device. We also some of the calls mentioned adhesion tests for inks and substrates. We also have a fairly simple wedge tester that we developed, and we've demonstrated with some electrically printed inks, measuring the adhesion of those inks, different substrates, and we subjected those to different environmental conditions like elevated humidity and temperature, and we did our wedge testing with those materials to investigate how the materials change with these elevated environmental conditions. And we also have a more standard uniaxial load frame machine that's meant to be used inside, do testing inside of an environmental chamber. So we can do that as well. We have a test resources machine that integrates within an environmental chamber. And also we have DIC for all these tests, where we can monitor the materials and get the localized strains while we're doing the mechanical testing of these. We also have a lot of capabilities with taking these this data and then also creating fine element models to understand their combined electrical mechanical behaviors. So ideally looking for some industry partners that have some applications that they're looking at, whether it's stretchable electronics or flexible electronics, so we can aid with mechanical characterization and then also some fine element modeling if needed. Like I said, like the calls were specifically asking for adhesion testing. That would be great. And also we have some projects that we've been doing proposals on for structural health monitoring for inflatable structures. So that would be another great project that we could be a part of as well on this. So yeah, my contact information there is at the bottom, and my lab's website is there as well.
Thank you, Nick. All right, we'll move forward to welcome Allie back.
Yes, thank you. This time I'll be presenting on behalf of our colleagues at the University of Dayton and the work we've been doing with them and how it pertains to topic 11.2. For this, we are not intending to lead a project, but wanted to present some of our capabilities if it fits with any of the gaps that current teams or industry partners might identify. So first, I wanted to demonstrate our capabilities and advancements we've made in material and manufacturing approaches to additively manufacture adjustable moduli substrates for flexible and rigid interfaces. So here you can just see that green substrate with a flexible electronic ink on top to show how one side is staying rigid and the other one is flexible. And in addition to that, we've also been developing more advanced flexible substrates specifically for high temperature applications. So think a printable Viton-like material that isn't available on the within the data or within the manufacturing base now, but we are working on developing that for flexible remote applications for extreme temperatures. In addition to that, UDRI has a lot of testing labs and capabilities, anywhere from custom built testing for specific applications to ISO labs. So once we start moving into integration and qualification of materials, we have the capabilities to kind of do both. So similarly, if any of these capabilities fit well into your team's need, we would love to talk more when we have more capabilities on top of what we just demonstrated here. So feel free to reach out. Thank you.
Thank you again, Ali. All right, we'll move back to Pradeep.
Thank you, Nick. This is Pradeep Lal. I'm professor at Auburn University and director of the Alabama node of NextFlex at Auburn. So this particular project, we are focusing on really health monitoring of critical infrastructure components. So these might be structural components. And the intent is to do persistent monitoring of these structural components to identify impending failure more specifically. We have done quite a bit of work on sensor development in our past activities, and some of those sensors are shown at the bottom. We have processes that we have developed to show stability of many of these sensors for prolonged time. So there is a graph in the bottom middle that shows data over 10 hours of operation of a sensor, of a printed sensor, additively printed sensor. And the intent is to really look at structural response under a bunch of conditions, vibration, temperature, corrosion of critical infrastructure, which may itself not be flexible, and to develop solutions that would allow the assessment of remaining useful life and impending failure of these structures in use cases that are reflective of austere environments. Partners that we're looking for, any OEMs that may have a use case that are requiring integration of sensors into a structural component, for example, or would like to partner with us on a product-like demonstrator that can be used for process maturation, sensor characterization, and data acquisition. I also want to point out that there is a QR code at the top right. If you scan that, that'll actually bring in my business card right into your iPhone or Android platform. So if you want to get in touch with me to discuss opportunities, activities that we'd be able to contribute, we'd be delighted to speak with you. Thank you.
Thank you, Pradeep. Now we'll move on to Dick Fink of Applied Nanotech. Dick, are you ready?
Good afternoon, good morning. Can you hear me?
We can.
Okay. So I am presenting on behalf of Applied Nanotech as well as Optimec and UMass Lowell. We have teamed in the past, and we wish to team again for developing high-density hybrid circuits for installation resilience. And what we're trying to do is leverage the technology that we've developed under SBIR programs to print indium traces and indium tin alloys that can be circuit traces, or they can be bumps for low temperature soldering. These materials can be laser sintered for to melt the solder, to flow the solder. We've also demonstrated mechanical sintering with something as sophisticated as a kitchen rolling pin. And both of these processes have demonstrated superconducting circuits. I'm not trying to promote superconductivity here, but just demonstrating that the material can be printed and soldered, or printed and sintered at relatively low temperature for applications on low temperature substrates such as paper or polycarbonate. So we're targeting low cost substrate materials and applications here. What we're looking for are partners or team members that have experience or connections with logistics and asset management. We have peripherally information on that, but we really need a subject matter expert to attack this problem. So there's additional information here, but I think it can be flexible depending on who the partner is. And I think I've said enough. Thank you very much. I welcome anybody to contact me. My contact information is in the center of the slide.
Thank you, Dick. Move on to University of Texas at Dallas.
Hi, everyone. Good morning or good afternoon. This is Ifana. I'm an associate professor in the Department of Electrical and Computer Engineering at UT Dallas. And our group mainly focuses on RF and microwave systems, specifically phased array antennas for various applications ranging from high power beaming for wireless power transfer to radar applications to wireless communication. So for this call, we haven't finalized the topic yet. We're still looking for partners in the industry, defense partners. But the overarching goal is to develop some sensors that can do remote sensing using phased array antennas, similar to radars. And here you can see some of the examples of what we have done in the past. We have demonstrated fabrication capabilities using Volterra V1. We have fabricated phased array antennas. We have done some bending testing to see how the resonant frequency changes, how the gain, radiation efficiency, and directivity changes as different bending happens. So what we would like to do is to have to find out a partner to really amp up the production capability. So right now we are doing bench level prototyping, but we would like to develop the go one step further and mature the technology in order to demonstrate specifically a working phased array antenna that can be deployed on a UAV surface. So that's our objective. And if you are interested to partner, please reach out to my email address and I'd be happy to talk more about the capabilities that we have at our end. Thank you.
Thank you, Afana. And then now we have Masood from Nanoprint Tech. Masood, go ahead.
Yes, can you hear me now?
Yep.
Excellent. Yes, this is Masood Majuri Samani, and I have two hats. I'm at Auburn University, and also I'm the founder and president of Nanoprint Tech. Today, I'm going to just emphasize a few things on Nanoprint Tech and how it can be applied to this call. Nanoprint Tech is the inkless printing technology. Basically, you can print any materials from metals to semiconductors to even nanocomposites using raw materials. So this is critical for, especially if you are thinking about, let's say, a standardization and qualification. So once you standardize this prints, that's a standard will basically live forever since you are using a raw material as your source. So you don't have to worry about changing the concentration, changing the the properties of ink and so on and so forth. The second thing is that this technology can be applied is the technology demonstration. Since you can do multi-material printing, composite printing, this can allow you to demonstrate various new technologies and new prints, basically new devices. And even and at the end, we have also done a lot of AI. Basically, we have the only fully autonomous printing system now that is capable of thinking, printing, and proposing to system all autonomously. So yeah, that's basically is available for possibly getting into collaboration or cooperation with other teams. Thank you so much.
Thank you, Masood. And I think that's all we have. Did anyone submit a slide that we didn't include? All right. If not, thank you all very much for participating in today's Proposers Day and our teaming event. I'm going to once again point you to proposal@nextflex.us as your main resource. If you have any questions on the way, feel free, don't hesitate to reach out. Happy to provide guidance and answer your questions. So thank you all very much. Looking forward to working with you all and receiving your proposals. Scott, do you have anything to add?
I will just say that I'm looking forward to the pre-submission consultation discussions with all of you, and looking forward to reading your proposals after that.
All right. Thank you, everyone. Have a great day.